data source, design patterns, and JSF. That's what we're looking at today. This is going to be the last learning block where I present a lecture. So next week there will be no lecture. You will just have some material to read through. It's about interface design, things like that, some principles of that. And I thought you could read that just as well as listen to me talk about it. So you'll find when that appears on Blackboard that you've got some resources to look at, and that will essentially be your self-taught lecture that week. In week 12, again, there will be no lecture, and that's just to give you time to continue working on your assignment so that you've got a little bit of extra time for that. In this learning block, we're going to look at 3 design patterns, all of them to do with data sources: the table data gateway, row data gateway, and active record. And for that, you'll need some concepts from previous learning blocks, the USDP, and what we talked about in the last learning block for design patterns. Unusually, we're not going to have to focus on the life cycle for JSF, which I think is possibly the very first learning block in which we've not had to think about that. Why would we want to focus on these design patterns? Well, it's because we've got a mismatch of paradigms in our systems. We're using object-oriented software. We're writing object-oriented classes. We are using, from those object-oriented classes, a relational database. And the two don't match. Therefore, we need some way of improving our system so that the mismatch no longer matters, and so that we can still maintain and extend our applications. What we've done thus far is to embed the SQL into the managed beans or the POJOs that they use, and this makes maintenance awkward. Database administrators cannot easily find the SQL code, and even if we were to put all the SQL statements into one class, into one interface, that doesn't remove the lack of OO structure. So we need to find some better way than that. Using the USDP has actually improved the situation for us, because we now have these handlers, these managers, that sit between the boundary class and the entity classes. And we saw that we can put all the database interaction into those manager classes. So now we've got those database interactions, the SQL commands, and all the methods that insert, update, delete, and find. All of that can go into one set of classes. So that is an improvement. And now let's think about how we could take it a step further. If we can separate the business classes away from the code that interacts with the relational database, we have a further separation of responsibilities. And as we've talked about all the way through this module, that separation of concerns is a key component of good software engineering. And so if we can do that, that will be good. If we can centralize database interactions, that's good as well. And if we can make those well-defined classes, even better. It makes it easier to maintain, easier to extend the functionality, it improves the OO structure, and so all round, it's a good thing. So we're going to look at 3 patterns, but don't go away with the idea that in your applications you should use all 3. They're not intended to be used together. So you would choose to use one of the 3 for an application. You don't mix and match. Let's start with the table data gateway design pattern. It's really quite a straightforward thing. It's got a simple interface. It's got standard methods such as update, insert, delete, and then a number of find methods that will perform the queries on the database. It will hold all the SQL for accessing a single table. In other words, this becomes a class that wraps up the interaction with the database for a given table. And that's why it's called a table data gateway. This will be a gateway to the database that will focus on the data that's held in one table. Here we have the structure. Whereas before we had from the USDP the boundary class, which is a facade, the manager, which is interacting with the database, and then some DTOs that get passed back to the boundary class. Now we've got the same classes, but we've introduced another 2. One for the customer table and one for the discount table in the database. When the customer manager wants to find something, then it will call the find methods in one or both of those gateway classes. So for example, it might call the find method, maybe find customer by ID method in the customer gateway class, passing the customer ID as the parameter. It will query the database, extract that one row from the database, and encapsulate that data in a customer DTO object, and then pass the customer DTO object back to the customer manager. But that still leaves in the customer DTO object a code for the discount. And if we wanted that information, then the customer manager would then issue another find call, this time into the discount gateway class, so that it will then query the database to extract the row that contains the data for the discount code. Set that up as a discount DTO and take that back to the customer manager, and the customer manager could very well call the set method to set up the association, the unidirectional association that you can see between the two DTO classes. Now that's one possibility, and that relies upon one class per table. Another approach, even though it's called the table data gateway, is to think of a table as being the result set table rather than the base table from which we're extracting data. And that's called a view. So we'll build a class for a given view. Now in our example where we've got a customer, that customer has got a reference to a discount. So in the view approach to this gateway, we would have a customer gateway class, just one, that interacts with the database. We'll have a find method such as find customer by ID. We pass the customer ID in just like we did before, but this time the SQL for that will query not just the customer table but also the discount table using a join to extract the discount information at the same time. And then we'll construct a customer DTO object and a discount DTO object and set up the association and return a reference to the customer DTO, which now holds a reference to the discount DTO as well. So you've got a couple of possibilities there. You can choose to go one way or the other. Let's take a look at the code for this example, which is available on Blackboard for you to download. You can see in the gateway package, I've got one class called customer gateway. I've got a couple of find methods. These are the methods that are going to issue the query statements for the database. Find for just a customer ID, and find for name, address, and zip code. So we've overloaded the find method. You could have called those something different if you wanted. Find by ID and find by name, address, and zip code if you wanted to. But I think overloading is perfectly acceptable. We've got a different set of parameters, and therefore the system can distinguish clearly between the two methods that are being used. Find all summaries, which is going to return an array list of customer DTOs, an insert, a delete, and an update. Those last three are pretty standard for this kind of design pattern. You want to be able to insert rows into the database, you want to be able to delete some, and also you want to update existing rows. So you will need all three of those in addition to the find methods. In the first find method, you can see we've got the select statement. So after connecting to the database, we're setting up a prepared statement using that SQL string. So one of the things that is good about this is the SQL is buried inside the code with the bit of code that needs it and is inside the class that relates to that view. It's not scattered elsewhere around the system. An alternative would be to take that SQL string and declare it at the top as a constant. And then all the SQL statements are defined in one place instead of one in each method. I suppose it's a matter of preference, really. And then we process that statement as we would have done anyway. The result being a new customer DTO. We're also, as part of that, instead of storing the code for the discount, we're creating a new discount DTO object and storing that inside the customer DTO object, so that we're setting up that unidirectional association that the design requires. You'll be able to look through this in your own time. Just a quick overview here. Again, connect to the database. There's the SQL statement. Use a prepared statement. This avoids problems such as SQL injection. And we do that all the way down. A similar thing in all of these. set up the connection, here's the SQL command, use a prepared statement, and then execute that statement. That pattern follows all the way down through those methods. Nice and simple to organize, nice and simple to understand, nice and readable, and it can be extended if you need to use a different table, then you've set up a different gateway class. You might have spotted that there's quite a bit of repeated code here. For example, the connection to the database. You might want to factor that out into a private method that will connect to the database, and each of these methods can then call that private helper method that will return the connection. So you can do things like that to improve the structure of the class. Then in the manager, all we need to do now is to set up the association that we saw in the class diagram between the manager and the gateway. So we're holding a private variable for the gateway, creating a new instance of the customer gateway, and then these find methods that previously were doing all that database interaction simply now call the appropriate find method in the gateway class. So nice and straightforward. Makes this class much more readable, much easier to see what's going on. This isn't a particularly tricky class, and so there's nothing else going on other than just delegating the method call over to the gateway. In more complicated scenarios, you could very well be calling that gateway and maybe another gateway, extracting it data, combining that data in some way, processing the data, and returning the result of that to the boundary class. The row data gateway is a variation of the table data gateway. Whereas the table has code that will interact with the entire table, the row data gateway has one object that represents a row, a single row. So when you extract information, let's say you're doing a query, find customer by ID, that's going to return one row of data from the database. Therefore, you'll have one row data gateway object that will represent that row. Therefore, we're combining that DTO idea with the table data gateway idea into one thing. You can see that because we've now got the database columns represented as fields within this row data gateway object. There will still be an insert, an update, and a delete method that will operate only on that one object, only on that one row in the database. So if you find that you've got a query that's going to extract, let's say, 10 rows, you will end up with 10 row data gateway objects. And if you wanted to delete 3 of those, then you would call the delete method in those 3 objects, and they would operate on that row that they relate to in the table. The find methods, therefore, are going to be separate. One way of doing that is to put it into a separate class. What I prefer to do is to make them static methods within the class that they relate to. So you'd have a find by ID method as a static method in the row data gateway. So if you had a customer row data gateway class, then you'd have some static find methods that would return instances of the customer row data gateway. And then the insert, update, and delete methods will operate on those individual objects. Now, although we've brought the customer DTO into this class, and we've got those columns represented as fields in the object, we will still not have any domain logic, any business rules in that class. That's still kept separate. So we've still got this class that operates with the database, but the business rules, those are stored in a separate method in a different class, and they should not mix, not with this pattern. And so our class diagram changes slightly. You can see that the customer manager is still interacting with the customer gateway, but this is now a row gateway. And so the find methods have become static. There are customer fields in here to represent the columns in the database table. Therefore, one set of data from one row will appear in one instance of this row gateway class. There'll also be one for the discount, and that association is preserved that there was between the two DTOs. But now that the DTOs are buried inside the gateway, then that association has to be moved across to the gateway classes as well. So this is possibility number 1. Possibility number 2 is that we continue to use the DTOs, because those DTOs are really quite useful. We could send them around the system. If we need one, we can get one out using the row gateway class and then pass that over to the boundary class. But the database operations are still contained within the row gateway. So if we were to take the customer DTO and pass that to the boundary class, the facade at the front, it will not be able to operate on the database because those operations are not in the methods that are held within the DTO. We haven't violated the idea of the pattern in as much as we've still got those database columns represented within the gateway, but it's represented as a DTO object. And the find methods, which are still static, they'll get that data from the database, set up a customer DTO object with that data from the database, and then store the reference to that DTO inside this object member here. Now, if we take the concept a step further, and possibly this is a step too far, we end up with an active record. Remember, I said that the row data gateway is separate from the business logic. Well, if we were to take that business logic and put it inside the row data gateway, we end up with an active record. The active record is a combination of the row gateway plus the domain logic. So it will still have one object of this type of class representing one row in the database. It will therefore have the insert, update and delete methods, but it will also have the business logic that will apply the business rules to that data. Now, there are some schools of thought that say, well, this is a step too far because we set off right at the beginning of this lecture saying we ought to separate concerns, separate responsibilities. And it might be that the interaction with the database will not vary over time quite as frequently as the business rules might change. And if you're changing business rules without changing the way that the database operates, wouldn't that be good only to have to change the business rules that are encapsulated in a separate class from the database interaction? Whereas if you're using the active record design pattern, then with the business rules in there, you're going to have to change that when the business rules change and then test your database interaction all over again because you've changed the class. Another thought is that this one class now has got two reasons to change. One reason is the business rules are different, and another reason is the database structure has changed. And now that you've got two reasons for change, then we're starting to perhaps violate one of the other rules about design, which is that each class should really only have one responsibility, one reason to change. Again, it's a matter of preference. It's a recognized and a valid design pattern, but you decide which you use. There are three of those that we've talked about. You choose to use one of them. So this class diagram looks very similar to one that we were looking at not so very long ago with the row data gateway. But please remember, it's different internally because the business logic is built into these methods in the active record, whereas previously they were elsewhere, very probably in the manager. Here's a thought. If we're using an active record, we can take that active record object, we can send it to the interface class so that the interface class can get the data that's just come out of the database. That's a good thing. But because it's an active record, it means that the insert, the update, and the delete methods are also available to that interface class. If we go back to the class diagram, it now means that this class, the facade, is able to instigate changes by skipping the manager altogether and calling insert, update, and delete in the active record. And that might not be a desirable thing. And so it might be considered good in as much as, well, it makes it more versatile, but it might be considered bad because it no longer protects the database in the way that we might want it. Another principle of software engineering that we might want to consider is the idea of only talk to your immediate neighbor. So the facade talks to the customer manager, which talks only to the active record. The facade here is not going to talk to the active record directly, because that would add an additional dependency within this class. And so that would mean if this changes or if that changes, because of the additional dependency, there's a possibility that this will have to change as well. So wherever possible, we want to minimize the connections between one class and another so that we can minimize the amount of change that is propagated through the system when something has to change within one class. If I change something in the active record, with the current example, All I've got to do is to come back out to here, which depends on that one because of this association, to make sure that the changes in the active record have not had any impact on here. Whereas if this is referencing the active record, then I'd have to check this class as well if I made any changes inside the active record. So you might start to get the feel that my personal preference is active record is not necessarily the best option. If you want to go for active record, then maybe a row data gateway would be better and keep the business logic separate. If you choose to use the active record for your assignment, that's not a problem. You can get just as many marks for that as for using one of the other patterns. You will not be penalized for using the active record, even though I might have a slight aversion to the active record. When you've finished this learning block, you will have got some experience with 3 design patterns and seen how they can be used in a JSF application.